Hello everyone, this is Black Body Engineering channel, and today I'm going to be explaining a few basic theorems that would allow you to understand how does Boolean algebra help us build the logic blocks and the building blocks of logic or digital logic. So we can start with some few basic theorems. We can start, for example, for x plus 0 is always going to be x. Another example is if x is ANDed to a 1, then that's going to be x. So whatever, if you have an OR function here and an AND function here, the x is always going to be the same. That being said, if I have an unknown value and it's OR to a 1, then that's always going to be a 1. And if an unknown value is ANDed with a 0, that's going to be a 0. For example, if I have an OR gate right here, an x, if I have a 0, then this current goes here. Or if I have an OR gate and I have a 1, then this is always going to be true. Same way over here, if I have an AND gate and I have an x and a 1, then the output is going to be dependent on the unknown value. And the same way, if I have another value here, then the output is going to be dependent on the 0. Another thing that we have, if we have an inverted value and we invert that value again, then we end up with x. For example, if I have two inverters here connected one after the other, and I have x here, then this is always gonna, oh, it's also gonna be x, because right here I have x inverted, and then I have x inverted again, and this one cancel each other, making my input the same as my output. Also, if I have a value that is OR with its inverted value, then that's always going to be a 1. Why? Because if I have 0 or 1, 1. If I have 1 or 0, that's going to be a 1. Likewise, if I have a value that is ANDed with its inverted value, that's going to be a 0, because the output is always going to be dependent on a 0. So if I have a 0 here, it cancels this one out, so it doesn't matter. So it's going to be a 0. So after going through this Boolean algebra, you can be wondering, how does this relate to building the circuit? So for example, how Boolean relates to digital logic circuits. Well, if we have A, B, or C, and that's equal to F, for example, then when you have this, you can see that this is an AND gate and this is an OR gate. So if we try to draw the or implement that, then we have A, B, and then we have an OR gate, and this one is fitting to this OR gate, and this one it's C. And then at the end, the final value is F. Another example that we might have, if, for example, if we have something like CD or C, D, F, or B prime, C, A. So, and then this is multiplied by A. So, first, to make this easier, we can draw the AND gates that are inside of it. CD. The next one is C, D, F. The next one is B, C, A. As you can see, all of them are OR gate, so that's an OR gate. And then at the end, it has an AND gate, so all of that's going to an AND gate, and that is my final value. And that's how you convert your logic equations into functional digital circuits.